Hello, welcome back to this subnetting of class C lecture continuation. This is video number 10, section 4, lecture 1 continuation for this particular class C subnet. Now we are in case number 5 where we are borrowing 5 bits. So if 5 bits are borrowed, 3 bits are left, and this is what we get the magic number, and this is what we get the block size, and this would be the new subnet mask. Please go through this. I have already explained all of them previously. Okay, now what happens, this is our first network 192.168.0.0, and if you look at this, the block size is 8, so this will give me the next subnet. Totally there will be 32 subnets. Each subnet can accommodate a maximum of 6 hosts. So 0.8, 8 plus 8, 16, 24, 32, and all the way to, so last would be 248. 1 less than 8 is 7. So 7 is the broadcast address for the first network. Likewise 16 minus 1 is 15. So 15 is the broadcast address for the second subnet. Likewise, one more than the network address would be the first valid host address, and one less than the broadcast address would be the last valid host address. So from 1 through 6 there will be totally 6 hosts. Likewise from 9 through 14 both inclusive there will be 6 hosts. So we got it according to the formula. We already got 32 subnets, 6 hosts, and from the block size we already calculated this different subnets, and this would be the new subnet mask for each of these subnets. So subnet 192.168.0.0 space 255.255.255.248 or 192.168.0.0/29, because 5 bits means 24 plus 5 is 29. So this is what we get after borrowing 5 bits. Please go through it. Okay. Now let us see what happens when we borrow 6 bits. So number of networks 64, number of hosts per subnet would be 2. So only 2 hosts will be there. Magic number, because we have borrowed 6 bits, the first 6 bits all would be 1 and the last 2 bits would be 0. So it is 252. Block size is 256 minus the magic number, it is 4, and this would be the new subnet mask. Remember, the last octet just replaced by the magic number that we got. So block size is 4. So if my first network is 192.168.0.0, so next would be 192.168.0.4, then again add 4 to that, so 0.8, again add 4 to that, 0.12, and so on and so forth. So 0.0, 0.4, 0.8, 0.12, 16, 20, 24 multiples of 4, and all the way to 252, because if I add 4 to this it becomes 256, and 256 is not a number within the 8-bit decimal value. Maximum is 255. So this 255 is the broadcast. Now over here, although I have given one column over here saying ... but these are all continuous. 192.168.0.0 is the network, 192.168.0.1 is the first valid host, 192.168.0.2 is the second valid host or the last valid host, and the broadcast is 192.168.0.3. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and so on. have a clear and good understanding of this particular subnet, because here we have got only two hosts and these addresses are contiguous, although these are network addresses and these are broadcast addresses. And don't forget that network address and broadcast address, they cannot be assigned to a host. Now this particular network where we got 255.255.255.252 or /30 in terms of prefix length, this particular network is useful when we have only two hosts in a network. Now this can be seen in a WAN connection between the two routers. Not necessary routers, we can make our computers also as routers. So if I have got two routers and I want to have a WAN connection between them, then I should always use /30 so that I don't waste IPv4 addresses. I just taken one example, 192.168.255.0/30. So next would be 255.4/30. Next would be 255.8/30, followed by 255.12/30. Now this is the ISP and this is the edge router. So edge router is generally used for your connectivity to the internet. So if you want that this public IPv4 addresses, there would be many different subnets over here. If you want them to communicate with the internet, then we cannot take this /30. This has to be less than /30. So on this particular router, we will be implementing NAT. So that NAT will allow all these internal private IPv4 addresses to communicate with the internet. And in that NAT technology, what happens, some port numbers are assigned to each of these hosts and they send their packet to the edge router, and then edge router sends that packet to the outside world by using this public IPv4 address and not the internal private IPv4 addresses. If host 1 sends a packet, then he gives one of the port number to it in its table. If another host sends, then he adds another port number. If another host sends a packet to the internet, then he adds one more port. So like this, there are 65,536 ports, of which some are reserved. So approximately 60,000 hosts can send the packet outside with the help of those different ports. So that port number is used to send the packet to outside the world from our private network with the help of a technology called NAT, Network Address Translation. That is just for your knowledge, so remember that. Now let us see what happens if we borrow 7 bits in the 4th octet. So if I borrow 7 bits, then the number of hosts per subnet equal to 8 minus 7 is 1, so 2 power 1. This is the formula, n minus 2. So 2 power 1 is 2, 2 minus 2 is 0. Oops, there are 0 hosts. You remember in the beginning I had told in the 4th octet we cannot borrow 7 bits, or we cannot have /31 as the prefix length. This is the reason, because I cannot assign any host in this particular network, or if we borrow 7 bits we cannot have any hosts. That is why this is not allowed. Now let us see a different case for a single host only. I am not saying single host, I am saying single host only. We are allowed to use /31 prefix length, which is same as 255.255.255.255. Now when we use this /32 or all 255, then that becomes a single host only. So that single host only is a network by itself, a host by itself. It is allowed. IPv4 allows it. You don't need any calculations in this. Simply assign an IP address of say 5.5.5.1 to 55.255.255.255 or 5.5.5.2 and subnet mask all 255, or you can simply say any address 6.6.6.6/32. Generally this is used in your large enterprises or small enterprises where we have a router and I need to assign a virtual interface. So I can assign a virtual interface to this router. There are configurations, different vendors, they have got different configurations. So I create a loopback interface address on this router and give that /32 IPv4 address for that particular virtual interface. This is the real interface which is present, and we create virtual interfaces. Virtual interfaces, they never fail. The real physical interfaces, they can fail. Maybe you have a router in your comms room and maybe night time somebody rat comes in and maybe fiddles with this and this port gets damaged. But that rat cannot fiddle with the virtual interface. So virtual interfaces do not fail unless until the device itself fail. So that is one of the scenario where we can use /32 or 255.255.255.255 subnet mask for a single host only address. In this section we used class C network 192.168.0.0. There are altogether 256 networks in this class, private class C network. Whichever network you decide to subnet, the same rule, formula, process, calculations, everything apply. Other networks in class C private network are 192.168.1.0 through 192.168.255.0. So these are 256 private subnets for class C network, private network. Pick any and do the same as we did in section 4. Start with basics, binary base 2 powers from 0 through 32, just know up to 2 power 10 and then 11 through 16 also, then 24 and then 32. Others will be in memory as you use them. Even I also don't remember 2 power 17, 2 power 18, but these values I do remember. Let us have a quick summary of class C subnetting. So this is the default 255.255.255.0 or /24. Remember, this is the subnet mask, this is the prefix length. So these two mean the same thing. So how many bits we have borrowed? We did not borrow because in default means what it comes. So we did not borrow anything. So that is why 2 power 0 equal to there is one single subnet. Hosts will be this formula 254. So when I borrow one bit, this interesting octet from 0 it becomes 128. When I borrow 2 bits, this interesting octets 0 becomes 192. Remember, these are the magic numbers. So 128, 192, 224, 240, 248, 252. Next would be 254 in the fourth octet. We are not allowed, and another would be 255. So /24, /25 up to /30. We have also seen 31 cannot be used and 32 also can be used. So number of networks increases. In fact, it becomes twice what it was previously. So 1, 2, 4, 8, 16, 32, 64. So in class C, these are the only values. These are the only number of networks that we can use by subnetting the default class. And the number of hosts decreases per subnet as we increase the borrowed bits, or with increase in number of networks, what happens? The number of hosts decreases. That should be all for class C subnetting. We have borrowed each and every bit and seen what is the corresponding result. You cannot do more than this in class C. Just take another subnet 192.168.1.0 or 2.0, 2.0, 3.0 and do the same thing again and again. The more you do, the more you understand. That should be it. Thank you very much for watching this video. See you in next section. Bye until then.